All right, guys, let's go ahead and talk about 4-2. So this is what we needed last time, kind of the definitions before we can do the triangles. Um, so if you're given a point on the unit circle, right, a circle of one, that's the one I gave you in the PDF. This is just the basic circle equation. So using your unit circle and your radius of one, you can find out these points. These points are going to correspond to the x and y values of these functions here. So basically, sine is the y value of a point on the unit circle, which is found by giving an angle t. So if the angle, let's say, is pi, which is right here, the x is -1, the y is 0, so the sine would be 0, because that's the y, right? And cosine would be x, which would be -1. Now, if we were to choose the angle 0, right, which is the beginning of the circle, we said we start there. Cosine of 0 would be 1, and this is the x value, and the sine would be 0. So we just got to define all these guys here and start creating our functions. Okay. So let me write these down, and I'm going to define them as angles and triangles. So here we go. Okay. So definition of the six trigonometric functions of acute angles. The six ratios of the length of a right triangle are called trig functions. So that's how you write the sine. So sine of a angle theta, which is the angle of the acute triangle, is defined as this ratio. The opposite angle, or I'm sorry, opposite side over the hypotenuse. I'm gonna draw the triangle over here. Right triangle, theta. So whenever we say opposite or adjacent, etc., we mean to the angle in question. The sine theta is opposite, which is over here, over the hypotenuse, which is that one should be clear, adjacent right next to the angle. Okay. Cosine of theta, written this way, is equal to the adjacent side over the hypotenuse. Tangent of theta and theta is equal to opposite over adjacent. So this is when we do the SOHCAHTOA. Now the other three, sorry, so is sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. It's an easy way to remember what these are, these three. The other three are just reciprocals of these. Okay. So cosecant of theta, written this way, is equal to the reciprocal. I think this is going to be reciprocal of sine. Yeah. So hypotenuse over opposite. It's going to abbreviate it a bit. Secant of theta is equal to this would be the reciprocal of cosine. And then cotangent of theta will be cotan theta equal to adjacent over opposite. So this is the reciprocal of tangent. So we're going to need these to solve the triangles, make things a little easier. Okay. Okay. Here are some reciprocal identities that I was talking about. Yeah, here's number one. We said cosecant theta is equal to 1 over sine. Number two, secant theta is equal to 1 over cosine. Number three, right, we said cotangent is equal to 1 over tan. Quotient identities. Then I'll go to the next page. Running out of space here. Is tangent theta, this is number one, is equal to sine theta over cosine theta. Number two, cotangent theta is equal to cosine theta over sine theta. So you can write it this way too. Yes, let me give you one more set of identities and then we'll start the problems. So Pythagorean identities. The main one is this guy. Sine squared plus cosine squared theta is equal to 1. And the rest come from this one. Now, the basic ones are just kind of moving things around. See how if I subtract cosine over, I get this. So basically solve for sine, solve for cosine, I get two more identities. Okay. Now if I divide by cosine and sine, I'll get two more sets. So if I divide everything by sine, this will become a 1. That'll become cotan. That'll become cosecant. That's how you can derive them. But I'm just going to give them to you for now. So 1 plus cotangent squared is equal to cosecant squared. Once you have that, by dividing, like I said, everything by sine, just move things around and get two more. So cotangent squared theta is equal to cosecant squared theta minus 1. And if I subtract the cotangent, I can isolate the 1. Cosecant squared theta minus cotangent squared theta is equal to 1. Now, if I divide everything by cosine squared, I'll get another set. I'll get the first one, and then I'll create two more. That'll become tangent squared theta plus 1 equal to secant. So now move things around, and we'll have all nine of them. For now, you don't want to derive them. You can memorize them or put them on a formula card, but that's how you create them. You're just doing some basic algebra, dividing by certain terms. Solve for 1 here. Um, this will become secant squared theta minus tangent squared theta. Okay, so now let's pick a question. Okay, so example 1. Suppose that the real number t corresponds to the point P, 5/13 and 12/13. So that's your point on the unit circle. Yeah, find sine t, cosine t, and tangent t. So remember that we said sine is defined as the y value on the unit circle. So the y value, sine of t, would be 12 over 13, right? Cosine would be the x value, so that would be 5/13. No real work here to do. Tangent, we said, is the ratio, right, of sine t over cosine. Oops, I should put a t there. Cosine t, which is the same as y over x in this case, because the radius would cancel, and also the radius is 1. So we can write it this way. So that'll give us 12 over 13 divided by 5 over 13, which cancels, giving us a 12 over 5. Okay, let me find the unit circle here. Okay, so here's the unit circle that I gave you last time. Also, I sent it on Remind. If they tell you what is sine of 30, right, you just go to the y value. Sine would be the half. Sine of 30, our t would be 30, our y would be a half. Cosine of 30, or cosine of pi over 6, which is the same thing, it's just two different units, remember? We were converting back and forth. The x value would be square root of 3 over 2. They say tangent of 30 or tangent of pi over 6, you take the ratio, divide y over x, or 1/2 divided by root 3 over 2. Okay, so that would be true for any angle on the circle. Okay, that's how we defined sine, cosine, tangent, etc. Okay, so we go back to our examples here. That's what we were doing here. That, well, this point is on the circle, so it's just some point, one of these, some random one that they made up. What is a sine, cosine, and tangent? Well, that's the y, x, y over x. The ratio, y over x. Okay. Excuse me. So I have a cold. Alrighty. This is basically what we're just saying. Right? Here's pxy. It looks complicated, but it's not. Number 3, they're like, okay, well, identify the ordered pair on the unit circle that corresponds to t of pi over 3. So find the sine, find the secant. So where's pi over 3? 5 pi over 3, right here, 300 degrees. Oops. So the sine would be the y value, root 3 over 2. And secant, we said, is 1 over cosine. So you would take the x value and take the reciprocal, because secant is the reciprocal of cosine, which is 1 over x, right? Okay, let's go back to the paper and do that on paper. Okay, so we found the order pair just a minute ago. We'll call it P at the 5 pi over 3. It's going to be 1/2 and negative root 3 over 2. So that's the point that they're asking about the order pair on the circle. So you go to that angle, 300 degrees or 5 pi thirds. That's the first part. Then they say find sine and secant. Well, sine we said is negative root 3 over 2. And secant t is equal to 1 over cosine, remember, or 1 over x in this case, which is 2 over 1. So there's our two functions they asked for. Okay, so the next one is they don't ask for the point, they just tell me find cosine and tangent at negative 5 pi 6, which is the same as negative 300 degrees if you were to um, convert it, right? Because earlier, well, actually, I'm sorry, that's not true. 5 pi thirds, um, is it 5 pi 6 or 5 pi thirds? Oh, 6. Okay, 5 pi 6 is actually on the circle. So when you're doing this, make sure you have your circle open. It's 150, so negative 150 for negative. Okay. And we said we can find the coterminal by adding 360, or you can go negative 150 in the other direction and find it. I keep forgetting to charge my calculator. So adding 360 to this would be the same as, let's see, where is the circle? Negative 180 would be all the way over there, so it would be 210 degrees. The coterminal of negative 150 degrees is plus 360, so that would be 150, 150. What did I say? 210, right? Yeah. Okay. So go to that place on the circle, either by going to negative 150 or going 210 around. The x value, I'm going to write the point, right? Just so we have it here. It's going to be negative root 3 over 2, comma, negative half. So this is like the p or whatever point on the circle. So cosine t is equal to negative root 3 over 2, and tangent t is equal to, remember, y over x, which is negative 1/2 over negative root 3 over 2. divide the fraction, you flip the bottom one, multiply, that would be negative negative would also make it positive, so let's just get rid of that. 2 over root 3, these two will cancel, leaving me with 1 over root 3. Now, we don't like roots on the bottom. Remember in college algebra, we said we need to rationalize. So you take this and multiply by root 3 on top and bottom. Makes like this. Okay, so the way you do this, right, to find any of the trig functions, if they tell you to find all six, it's just remember the definition we wrote down at the beginning, find the location, find the point, remember which one's x, which one's y, which one's defined the way it's defined. Sometimes you have to do a little rationalization, which is what we did here with the square roots. This is called rationalizing the denominator. That gets us to here. Okay. Okay. And so make sure you write those notes down on a formula card. Here's some more in the notes inside Canvas. This is the one I'm following right now in our example. Right, so sine is equal to y, cosine is equal to x, right? That's how we define it. Tan t, y over x. So these are all kind of like your identities. And they're just rehashing the ideas. There's some undefined points because when you have ratios, you can't have zero at the bottom. So that means the reciprocals won't be defined in certain spots. Here's the domains and ranges. We'll probably talk more about that later, but all this, I think I've written most of this already on the paper, but you can add some more details. Okay. Now, if you're given uh, the values and not the angle, you have to use triangles to solve the triangle. Or I'm sorry, you got to use the Pythagorean theorem to solve your triangle, and then you can find the other uh, functions. So let's go ahead and do that. So there's a couple ways you can do this. I said you can do the triangles, or you can use the reciprocal identities like the instructions said, but yeah, it's kind of boring. But check it out. Um, if the angle T is the one we're talking about, instead of theta, they use T for whatever reason. We said that the top is opposite over hypotenuse, so opposite to that angle is 15. Hypotenuse is 17. Adjacent is 8 over hypotenuse, so 8 over 17. So I got the entire triangle. So if they want me to find tangent and cosecant, I don't have to do reciprocals or anything. I can find all the trig functions like this. I'm gonna write them all down. Tangent was opposite over adjacent, such as 15 over 8, because they're right there. Reciprocal of cosecant, t is technically, we said, hypotenuse over opposite. In other words, flip over the sign. Or go to the triangle and go, okay, well, hypotenuse over opposite. Secant is a reciprocal of cosine. If you look at the formulas, hypotenuse over adjacent. In other words, just flip over cosine. When I say flip, take the reciprocal. Cotangent T would be the reciprocal of this one. Adjacent over opposite. So when you have the triangle, you can find all six. And if you have one of these, one function, you can use Pythagorean to find the missing one, or if you have sine and cosine, you can build the triangle right away. Doesn't matter. So I found all six, even though they only asked for tan and cosecant. So just remember the formulas, right? At the very beginning. I wrote them all down at the beginning. Opposite and hypotenuse, etc. Right? That's what I use. Okay. Okay. So I'm gonna change to theta because I'm tired of the T. It looks ugly. Looks ugly when I write it anyway. So something you need to know before we move on. So we've been assuming first quadrant for all of these, but that's not always true. Depending on the location of the angle, um, the sign of sine, cosine, etc. will change. So if it's in quadrant one, we know that both x and y have to be positive. Remember, it's quadrant one. If it's in quadrant two, the x is negative, y is positive. Remember, quadrant goes one, two, three, four. If in quadrant three, they're both negative. If it's quadrant four, then x is positive, but y is negative, right? Because right, this is my y-axis, my x-axis. Over here, we're both above zero, they're both positive. Over here, x goes to negative. Down here, they're both negative. Down here, only the y is negative. So if you don't remember, just make this little note, like, okay, x and y, right? X, y. Looks like a little owl or something. The coordinates are going to be this sign depending. Now, where is 3 pi over 2 to 2 pi? That's going to be, if you look at your circle, look at your circle. Three pi over two is right here. It's saying go from three here. It's saying that theta, that angle we're talking about, is going from here to 2 pi. 2 pi being 360. So if I start at 0 and do 360, I'm back where I started. So 2 pi and 0 is the same location. So from here to here um, is where angle is at, is where theta is located. So all the x's are positive, all the y's are negative. So when we're solving for sine, cosine, x and y, we have to remember that y must be negative, which means sine is negative and cosecant and tangent. And you'll see why, right? Because they're going to have a y in it. Also, when you do the Pythagorean, when you square root both sides, you can get plus or minus. So you choose the minus whenever you're solving for the y part. All right, let's switch back to the paper. Okay. So theta is in the fourth quadrant, which means x is negative, positive, y is negative. So we just said. Secant was defined as, let me write down everything. Sine theta opposite over hypotenuse, which is something. Cosine theta is equal to adjacent over hypotenuse. Cosecant is hypotenuse over opposite. It's the reciprocal of sine. Secant is the one they gave us, which is hypotenuse over adjacent. So hypotenuse is going to be 3. Adjacent is going to be, oops, no, that's not right. Hypotenuse is square root 11. adjacent is 3. So we got to find opposite. Right, so remember, x squared plus y squared equals r squared. We have x, which is positive. We need to find y. We have r, right? Solve for y, subtract that 3. That would be square root 11 squared minus root 3. I'm sorry, 3 squared. So y squared would be equal to 11 minus 9. Y squared is equal to 2. So y squared, square root both sides. Got to tack on that plus or minus. Y is equal to plus or minus root 2. Now we're going to choose negative because of quadrant 4. Negative root 2. So now I can solve the question. Whatever the question was, I already forgot. Let's see. Question was find tangent, but we can find all of them, I guess. I'm just writing all the formulas down just in case, just for fun. Okay, so cosine and secant are pretty much given to us. So here's secant. Here's cosine. Here's sine, right? Opposite over hypotenuse. You should rationalize that, but we're not going to. Cosecant, hypotenuse over opposite, that would be negative. Tangent would be opposite over adjacent, so negative root 2 over 3. Adjacent over opposite, which is the same as putting the negative in front, but technically the y part is negative. But the one they wanted was tangent, so that's this guy right here. I found out 6, so you can see where the negatives go. Yeah, it's all depending on which one has a y. So anything that has a y in it, or an opposite, right? Same thing. It's going to be minus, opposite, minus, opposite, minus. Okay, let's move on to the next one. So remember, if they mention where theta is, you got to take into account the sign. All right, so the last thing in this section is the periodic properties and the odd and even trig functions. And I'll post this so you don't have to write all this right now. But basically, if you were to add 2 pi inside, it just ends up with at the same place. So the first 4 functions, when you add 2 pi, you end up doing nothing, kind of like adding 360 to any angle theta. Now, if for the tangent and cotangent, if you add pi, then you end up where you started. So that's because of the period, but those period properties will do this. Okay. Also, the even and odd functions. Even, there's only one even is cosine and its reciprocal secant. Odd are the other 4. And if you remember, even property means that if you plug in a negative, that's the same as plugging in the positive version of that number, or in this case, angle. Negative, secant of negative theta is the same as secant theta. The sine of negative theta is the same as negative sine. Cosecant negative theta is the same as negative cosecant. Tangent negative theta is equal to negative tan theta. Negative cotangent. Cotangent negative theta is equal to negative cotan theta. So in the homework, you'll have some examples where they plug in a negative and you just use these properties. It's nothing crazy. But we'll stop here.